Hey guys, sorry I'm not in class today. I'm going to go over some of the stuff with you that you're going to be doing today. We're in 9.1.4. First off, I'm going to go back here. These are the answers to last night's homework. You can pause this video, take a look at those answers, and check your work. We can talk about those on Monday if you have anything that you need to go over. In 9.1.4, you're going to be graphing and interpreting the cosine function now, and you should figure out that it's going to be very similar to the sine function. Some of you may have even figured that out in your presentations the other day. They're starting us off on 9-37 with another unit circle. You can think of that like, it's just like the screamer, except it has the radius of 1 instead of 100. And it says to work with your team to write the coordinates of point P. So we're going to start thinking about this instead of being a triangle with a height. We're going to start thinking about points on unit circles as just points on unit circles that have an x and y coordinate. So if I were to take a triangle here and bring it up to point P, then you can imagine that if I found the x and y coordinates of P, that would be the same thing as the base of the triangle here and the height of the triangle, right? So you found the height of the triangles the other day when you were looking at the screamer, and when you were doing that, either the worksheet or going through those triangles to find the sines. So this x distance here is going to be the cosine function. So the cosine is going to be the x and the sine is going to be the y. So you want to figure out those points that go with point P based on that angle. Then in 9-38, see if you can generalize and write the points for Q without being given a specific angle, and I kind of gave you a big hint there on the last problem. 39 says, in a unit circle, how can sine be used to give you information about a point on the circle? What about cosine? So what information does sine and cosine give us in relation to that point? But again, I sort of talked about that a second ago. 40 says, if you know the sine of an angle on the unit circle, can you determine its cosine? How? Work with your team to create a strategy and be prepared to share that with the class. Think about how you would do that. If you had the sine, how could you get the cosine? I'm just going to go back to triangles in the unit circle. 41, the angle theta in a circle at the right has a cosine of 3/4. What are the exact coordinates of point Q? Use the Pythagorean theorem. What is the exact value of sine theta? It might be helpful here to draw a triangle and think about what cosine is, right? Cosine is adjacent over hypotenuse. And then think about what sine is, being opposite over hypotenuse. You're going to be drawing a lot of triangles in this section as we go through the unit circle, and you want to make these connections between the triangles and the circle. So draw a triangle with an angle. Figure out how you're going to incorporate this 3/4 into that triangle so that you can then go find the sine. Problem 42 says obtain this resource page, and basically you're going to create what you did with the sine function, but with the cosine function. If we look at this resource page, it's actually this one right here. This should look pretty familiar to you. I'm not going to give you this page, but I would like you to try to sketch this out and think about what this graph would look like. When we did sine, we were interested in, again, the height of each of these triangles. Now that we're doing cosine, we're interested in the base of each of these triangles. If I were to plot the base of the triangle on my y-axis and the theta on my x-axis, what would that look like? After you've sketched it out in your notebook, it might be nice to go back to the other function that you have, or the other piece of paper that looks just like this, and using a different color pencil or pen, sketch the cosine function on top of that, because that's what you're actually going to be doing. You're creating the cosine function when you're dealing with the base of those triangles. Alright guys, once again, sorry I wasn't in class today. Once you finish that up, your homework tonight is going to be 45 to 50 or 51, whatever it says on the assignment board, and we'll do some more work with cosine on Monday. Good luck.